Sup guys, so in the previous video we saw that the metals are on the left side of the periodic table, which is group number 1, 2, 3, and the non-metals are on the group number 4, 5, 6, 7, and they are the non-metals which are on the right hand side of the periodic table. We know the metals lose electrons, so they can have a stable shell, they can have a stable noble gas like configuration, so they become plus charges. And the non-metals gain electron, they gain electrons so that they can have their again a stable noble gas like configuration, and they gain electrons so they become negative charges. And the center part of the periodic table is full of transition metals, which are metals, so they become plus charges obviously, but their charge state is not fixed, so they do not have a group like phenomena. They can be having a charge of plus 2 or plus 3 or plus 4, but we will be talking about them in the later part of the chapter. In today's session we're going to talk about the nature of bonding. So we'll see more about the bonding, and we'll see how different kinds of bondings can be over here. So I am going to again copy this part of the periodic table from this portion till over here. I'm going to copy it again with the part that says metals and non-metals. I've copied it and I'm going to put it over here. So I have again my periodic table here with us. And now we should know that when you have a pure metal, or two or more metals, when you have only metals, so you can say when you have only metals, the bonding which is present within the substance, within the metal, it is known as the metallic bonding. So within a pure metal, even for multiple metals together, the bonding is known as metallic bonding. What happens when it is a pure non-metal? What happens when you have two or more non-metals? So when you have multiple non-metals, when you have non-metals in a combination, what happens is that we have a covalent bonding. We have a bonding which is known as covalent bonding. Covalent bonding. And what happens when metals combine with non-metals? What happens when one metal combines with one non-metal? What happens then? So in that case we have a combination of metal and non-metal, and the bonding is known as ionic bonding. Ionic bonding. Let's have an overview of these three kinds of bondings which are present. When you have a pure metal, it is metallic bonding. So what happens is that all the atoms are metal atoms. It's purely metal atoms. So you have multiple atoms of the metallic element. Let me have a color. Let me have this color. Let's suppose this is the atom of the metal. This is another atom. This is third atom. This is fourth atom, because they are all metal, right? And then I'm going to copy it, and I'm going to have more of those. So I have more of those over here, and I'm going to paste one over here as well. So these are multiple metal atoms. What they do is they lose their valence electrons. Remember, this is what we talked about, that metals always lose their valence electrons. They always lose their outer shell electrons. So all the metal atoms lose their outer shell electrons and they become plus charges. And when they become plus charges, what happens to the lost electron? The lost electron keeps on revolving in the area around the metal atoms. So this is the valence electron which has been lost. So we have two important labelings over here, this region and this thing. We have a lattice of metal ions. A lattice means a repeated structure. So we have a very large lattice of metal atoms which are now ionic. They are plus charges, so we call it lattice of metal atoms. And here we have a sea of mobile electrons. A sea of mobile electrons. So the metal atoms lose their electrons, and the lost electrons keep on revolving in the area around the lattice, and now it is known as the mobile sea of electrons. This is metallic bonding. In metallic bonding, we have a lattice of metal ions surrounded by a sea of mobile electrons. Now what happens in the covalent bonding? In covalent bonding, the metals, there is no metal, right? So the non-metals technically don't lose electrons, they gain electrons. But what happens if there are multiple non-metals? In covalent bonding, the non-metal atoms try to share electrons. So they try to share electrons. For example, this is a non-metal atom with another non-metal atom. For example, this is oxygen atom with hydrogen atoms. They share their electrons. So they share electrons. Hydrogen brings its electron, oxygen brings its electron, and they share it. Similarly, for example, if you have a nitrogen atom, which had 5 electrons in the last shell, for example, it shares its electrons with hydrogen atoms. So it brings hydrogen atoms and it's asked the hydrogen atoms to share electrons. So the hydrogen atom brings its electrons and nitrogen atom already had its electron and they share it. Similarly, let's have another example. For example, let's say if it's a chlorine, let's suppose some other color for it. Let's suppose I bring, let's say, this orange color. If you have one chlorine atom which had 7 electrons in the last shell, so chlorine had 7 electrons in the last shell, and there's another chlorine atom, so it's another chlorine atom like this, and it also had 7 electrons in the last shell. So one chlorine atom makes a bond with another chlorine atom. This region over here, it's a covalent bond. It's a covalent bond. It's made by the sharing of electrons. So covalent bond is made by the sharing of electrons. There is no mobile sea of electrons, but we have a sharing of electrons when there is covalent bonding. What happens in the ionic bonding? So ionic bonding is another trick. In ionic bonding, metal loses the electron, non-metal gains it. It's very simple, right? So the metal atom will lose their electron. So the metal, for example, sodium, will lose their electron. It will become a plus charge. Any non-metal, let's say chlorine. Chlorine will gain electron. It will become a minus charge. So sodium will lose its electron and chlorine will gain it. So over here, let's write the definition of each individual bonding. In metallic bonding, it is, we can write it over here. Let's say I can move this a little on top. I can put a box around it so we know what's going on. I can put a box over here and I can write the definition. In metallic lattice, it is a lattice of metal plus ions. They are surrounded by sea of mobile electrons. In covalent bonding, it is sharing of electrons between non-metal atoms. In ionic bonding, it is attraction between a metal plus and non-metal minus ion, between a metal's positive and a non-metal minus ion. So we know the definition of each kind of bonding that happens. When it's only metals, they don't give their electrons to something new, but they just lose their electrons and they make a lattice of positive ions and the electrons make a sea. In covalent bonding, the non-metal atoms share their electrons, so no one loses. And in ionic bonding, a metal loses the electron, the non-metal atom gains it. So the metal is a plus ion and the non-metal is minus ion. So far we have seen the 3 kinds of bonding with their definition. In the next video, we'll see the individual criteria and the individual properties of each kind of bonding. So stay tuned guys, things are gonna get really interesting.